All right, people, welcome back. So today we're dealing with a medium problem, 3 sum closest. So let's see what this problem is about. We already dealt with the 3 sum problem. Let's see if we can reutilize some ideas from that problem. So given an integer array nums of length n and an integer target, find 3 integers at distinct indices in nums such that the sum is closest to target. Is closest to target, not equal to target. That's basically the difference between the other problem we worked with, as far as I remember. You may assume that each input would have exactly one solution. So for example, 1, 2, 1, minus 4, the target is 1 and the output is 2. The sum is the closest to this closest to the target is 2. Minus 1 plus 2 plus 1 is equal to 2. Okay, now I see, okay, it's not immediate, to be honest. So I should return not the indices, I have to return the sum itself. Okay, that's very strange. That's very strange, to be honest. Okay, of course, the first thing that comes to my mind is I have 3 iteration for all I, and then for all I, for all j, and for all key. So I basically take all the triplets, I sum all of them, and each time I compute the sum, and I see how close it is to the target. Then, of course, last time, if I remember correctly, we simply fixed one number, and then we did an iteration, 2 iterations, like for I, we took all the couples, basically. And we tried to see if they summed. Okay, no, actually, we could sort nums. Okay, this is what I remember from last time we approached this problem. So we can sort nums. So I can do something like nums equal to sort. Okay, and now that I have my numbers sorted, what I can do is to simply fix. I fix a number, which is always the number at the left. Okay, so for example, my first one will be minus 2. So of course, left is the index. So minus 2 is at the index 0. Then what I do is to simply write down something like, for I, I want to use, okay, so my idea is to basically copy the solution for 3 sum and see if it works even in this case. So I remember that was working with the 2 pointers solution. Okay, so the idea is that we define also I that is equal to left plus 1, and j, which is equal to, let's define also n as the length of nums. J is basically n. Then what we can do is to simply say, while I okay, no, maybe I need to for loop. Okay, a lot of okay, I am a bit confused. Let me try with this. So I do a for loop for left in range n minus 2. Yes. So let me cancel all of this. That what I do is to initialize I as left plus 1. And j is of course equal to n minus 1. Okay. So these are going to be our 2 pointers. Then of course I have to define nums left. It's basically my target. Okay. So I want to take 2 numbers, like the 2 indices I and j. So nums I and nums j, they should sum to the difference between target and nums left. So let's call it difference. Difference is equal to target minus nums left. And then what I do is to simply say, while I is less than j, and no, that's it basically. That's it. If I simply say nums I plus nums j is equal to current. And now we want to check if current is less than difference, I want I to increase. If current is greater than difference, I want j to diminish. Then let's put it elif, and then of course if they are equal, I return target, because of course if they sum exactly to the target, then it's the target itself, the sum of the three numbers. Then of course, even if they are less or greater than the real difference, since we want the closest, we want to take like to see how close it is to the difference. So let's say that if let's define something that we can call current distance, and let's initialize it as inf, and then if the current distance is greater than current minus difference, then the absolute value of this, actually this, then we update current distance as the absolute value of current difference. Actually, no, this is not an underscore, this is a minus. We can even put it outside of this if statement. We can put it here. So my idea is if the current distance is different from all of this, then we go on and then we return the target. It should work. Okay, I'm not authenticated again. Sorry, 1 second. Okay, here we are again. This was wrong. So you see my idea. So we basically implemented 3sum as it was when we solved it last time, but this time instead of just using the sliding window technique, we are also taking into account the current distance and seeing if this current distance is greater than the absolute value. And in that case, we want to update the current distance. Oh, of course. Okay. Yeah, that's very stupid of me. If the current distance is then updated, I want then to save the closest number. So the closest is then equal to nums left plus nums I plus nums j. Then, of course, when we go outside of this while loop, this means that left must be updated. We add 1 to left. All right, so time to submit. Okay, let's run it first to see if it works. Then it doesn't work. That's fantastic. The output is null, and yes, that's because we are not returning anything. What should we return? We should return closest. It is accepted. It's incredible how messy it is, this code, but still it works. So let's go. Let's see. Incredible, it works. I'm really surprised by the fact that it does work. So in terms of complexity, since we're using the same strategy, and since we are also sorting here, of course we're moving left, like this is already ON complexity, and this can be ON. So the total is going to be ON squared in terms of complexity, which is not bad though. It's not bad. Well, first of all, left plus or equal 1, this is completely nonsense because we have left in the for loop. I forgot about that. Okay, anyway, so I think the problem is solved. So thank you very much for joining me in this process. Thank you very much for watching this video and see you in the next episode. Bye bye, guys.